We can identify the key features of a function and its derivatives using graphical, numerical, and analytical representations. And you may be given either graph or either representation to predict and explain a behavior of the function. So we can observe the behavior of the derivative over the open interval from -infinity to 0. So it's positive, and therefore the function is increasing. And the same from 0 to infinity. So the slope of the tangent to the curve is always positive. But at 0, the slope of the tangent to the curve is 0. So therefore this is indicative of a critical point. And you can see that from the analytical representation. But at this critical point, the graph is neither concave up or concave down. So at x equals 0, it's really an inflection point. And from -infinity to 0, you can see the second derivative is negative. So therefore the graph is concave down. And from 0 to infinity, the second derivative is positive. So the graph is concave up. And we'll get some practice on sketching the curves of functions and its derivatives using several examples.